Okay, so vectors. This is a GCSE recap because some of us did not do this at GCSE. Ready for Pure 4. So this guy's called Vector. He's from Despicable Me, and he's called Vector because he has direction and magnitude. I highly suggest watching the YouTube video. It's very funny. So let's have a look at what a vector is, and we'll have a recap. Okay, so we're going to remember how to write in vector form. For some of us, we're going to like add and scale, etc. We're going to do all sorts of things. This is everything we're going to cover in this lesson, okay? So, recap. What does anyone remember or know about vectors? Okay, so from our recap, here we go. We know that they're written like this, okay? Let's say this is 5, 3. Okay, the top number is our x. If it's positive, we go right. If it's negative, we go left, okay? Our second number is our y. If it's positive, we go up. If it's negative, we go down. Do you remember back in probably year 7 when we did transformations of shapes on a graph? And it'd say, transform this shape by vector. And it'd give us the vector. Well, that's where this starts at. So, here we go. Vectors, as we know, magnitude and direction, yeah? So, it tells us the direction. It tells us, it's different to a coordinate, because this coordinate, what's this coordinate here? 2, 3. Okay, so we would write 2, 3. However, a vector, we're saying if we started here and we end here, okay, what's happened? Well, we've gone across 1, 2, 3, 4. So that's 4 across. And then we've gone up 1. So that is how we'd represent that direction. Now, the magnitude is the length. So if we wanted to work out the length, what you find, have we just drawn a right angle triangle? Okay, so we can do 4 squared plus 1 squared and square root it. Yeah? So it's root 17 would be our magnitude, because that would be our length. Okay, so it's just a quick recap. So what you're going to quickly do is you're going to represent these as vectors. Now, remember the direction of the line. For A, for example, we're going this direction. For C, we're going this direction. So it tells you where to start. So we start here for this one. For D, we would start on this side because of the direction it's going. Okay, give this a quick go. Okay, so for A, we go across 1, up 3. So our vector is 1, 3. For B, if we start here, we go across 5, up 1. Okay. For C, if we start here, we go across 2, down 3. So this becomes 2 minus 3. Yeah? Okay. For D, we start here, now you can see we go to the left. So minus 4 and up 2. Okay, and then what are the other ones? Let's go. E. Minus 4, minus 4, perfect. F. Minus 1, 1, brilliant. G. 0, minus 3, perfect. Okay then, so this is writing it in number form, which is something that we have to recap. Now what we're going to do is write in this in, sometimes instead of writing the numbers each time. So here we know that vector A is 2 across and 5 up. Okay, so A is 2, 5. However, you know mathematicians, slightly lazy, but also geniuses and innovators, instead of writing 2, 5 every time, we would just write A. So instead of writing this all the time, we're just going to write A. So we're saying A is represented by this. A represents this. Yeah. So you can see here, this is A.
So that's the way they want us to format it? Like
No. No. Don't worry about if they see it on a diagram or anything like that yet, okay? I'm saying to you, sometimes, because if I was going to write A plus B, I wouldn't, instead of writing 2, 5 and then this, I would just write A plus B, knowing that this is what it meant. Right, instead of writing B right back on text, what do you write?
B what?
B right back.
Oh, BRB.
Yeah, so you write BRB. Well, I write A instead of 2, 5. Do you understand? Yeah? Happy? What's it called? BRB? Is it an acronym?
Yeah. No.
Is it?
Yeah, I think so.
Yeah, basically this is what a vector is. We're representing 2, 5.
An abbreviation.
An abbreviation. What's an acronym then?
An acronym is like a word that if you move the letters around, it becomes another word.
UAE. United Arab Emirates.
That's also an abbreviation.
Wait, someone Google this. Okay, so we're all right. An acronym is a form of an abbreviation. That's fine. Yeah, so this is what we're doing. At the minute, you're just learning about this. Don't worry how we're going to apply this yet. You need to understand the notation. Okay? So, there's 3 ways in which we can represent the vector z from point x to z. Okay, how could I do that? X to z. I can either write like this. This means x to z. Okay? How else could I say x to z? I could just write the vector A. How else can I say x to z? I can write this in vector form. 2, 1, 2, 3, 4, 5. These are 3 different abbreviations for me to get from x to z. Okay, now in GCSE I wouldn't go this far, but we're going to pure 4. There's another way we can go from x to z. Is everyone happy? X to z is clearly a straight line. Okay, what's another way I could get from x to z? X, Y, Z, absolutely. I could go this way round. X to Y, and then I could go X to Y, and then Y to Z. Could I not? I mean, it might be a longer way, but why would I do that? You're going to see why in exam questions. This is the whole point of vectors. Sometimes you have to think abstract. Sometimes you don't know how to use this path. So sometimes you have to go the long way round. As long as you know there's more than one route. So, I could then do x to y plus y to z, couldn't I? Okay, so for those of you who've already done vectors, how could we do x to y and y to z? Well, first of all, let's figure out. We are skipping a bit ahead, but that's okay. We'll recap this. How do I get from x to z? From x to y. I do x to z plus z to y. Yes? Okay? Because I don't know. Does this one tell us what it is? And imagine there was no grids. Yeah? We can see here what it is. However, imagine there was no lines. To get from x to y, x to z and z to b, which is a plus b. Yeah? So a plus b, and then if I go to y to z, from z to y, it's b this way. So if I go against the direction, it's minus b, which then leaves me a plus b minus b, which is a. We can see here that x to z is a. So going this way round is still the same as this. Okay? So that's a quick recap. So remember, all we're doing right now is looking at notation. We're just understanding what all these letters and stuff mean. So, A is 4, 3. 2A is double this, which is 8, 6. Okay? We literally just double both the values. Okay? So, have a look at this. What's the same about A and 2A, and what's different about A and 2A? Okay, so the same things we've noticed so far. They're both going in the same direction. Okay? They are both straight lines. Okay? Anything else that's the same? Pardon? Yeah, they're both scalars of A. What does that mean though?
So the same like proportion?
The same proportion? What would we call proportion with straight lines? For every whatever we go across, we go up this.
Magnitude? Magnitude?
Gradient. They have the same gradient. They are parallel. Yeah? Okay?
Yeah.
Brilliant. What's different about them? The length, absolutely. Okay, so what's the same? The gradient and obviously the direction. And what's different? The length. Okay, so what we notice though is that they are parallel. Okay, so that's our first kind of thing. You know, when we have a scalar, they're parallel. When one vector is a factor of another vector, the lines must be parallel. They must have the same gradient. So, here we go. This is actually what we looked at just a second ago, the same thing, okay? So, xz is A, which we already know what it is, yeah? It's 2, 5. Okay, zy is B, which is 2, 5, 3. Okay, xy is, if I went from x across and I went all the way up to y, I would get 7, 8. But we noticed earlier, if I was going from x to y, how would I do that? I would go, because I don't know, do I know the length of this route? No, not just by looking at it. I could count the squares, but we're not going to count squares. So I would do xz plus, so I would do xz plus zy, okay, which is the same as xz is represented as A, isn't it? Zy is represented as B, so it's the same as A plus B, because we're still going in this direction, okay? What is A represented as? 2, 5. What is B? 5, 3. If I add them, so if I add the x, 2 plus 5 is 7, and 5 plus 3 is 8. That is exactly the same as us counting squares. This is just proven that we can add vectors in this way. Because when we deal with vectors in a moment, we're not going to have this grid. Okay, here we go. This is what I'm talking about. Have I got a grid? Have I got numbers? No, in this time I just have vectors. So, we're going to go through this together. Okay, how do I go from O to B? O, B. I go from O to A, and from A to B. And is it all in the same direction? Okay, so that means I'm adding. So I do OA plus AB, which we know can also be written as A plus B. However, I would just write A plus B. Okay, how about if I was doing O to Y? How would I get O to Y? What would I do? O to Y. O to A, which is A, plus AB, because I'm going in the same direction, that's why I'm adding, which is B, plus BY. Can I simplify that? A plus 2B. Okay, A to X. So where do I start? AB, which is B. Plus, now watch this one. Minus 2C. Why have I gone minus 2C? Yeah, because I'm going against the direction. So it's not plus, this becomes minus 2C. So this is B minus 2C. Perfect. Okay, how about X to O? So where do I start? X, 2C, I'm going in the same direction. Then minus B. Then minus A. Okay, and then lastly, Y to X. Y to X. So how would I go from Y to X? I start at Y, I go minus B. That's why I love highlighters for vectors. And then to X, minus 2C. Okay, so as long as we can write these vectors, we're on a good thing. Now, this dotted line, you wouldn't see this in the exam. This is something that pops up after, it's just like a fact. If you were to draw this here, okay, it's still parallel. Parallel vectors, we know, are the same if they have the same length. They're represented by the same thing, okay? So sometimes if you can't figure out a way, you know, you can use parallel, but this is what it's showing is from O to B is A plus B. That is the same as doing B plus A, okay? It's the same thing, that's what that's showing. Okay, for this one, I want us to write the vector, AD. What is AD, please? Okay, so how do I get from A to D? Well, if I look, A to D, there's nothing here. It doesn't tell us what this is, does it? Okay, so I need to look for another way to get from A to D. Give me another way.
There's A plus B plus 2A.
So A to B. Okay, so I could go A to B, which is A, B to C, which is B. Now, when I do C to D, what do I notice? What's this? It's minus. So C to D is minus 2A. So I get A plus B minus 2A, which simplifies to B minus A.
Yeah.
Okay? Okay, so what did we get for BA? Minus A. What did we get for AC? A plus B. DB. 2A minus B. AD? Oh, we already did this, didn't we? B minus A, because it's A plus B minus 2A, so that's B minus A. Yep. Okay, question 3. MK. Minus A, M to K. Yep, I mean, I would minus A minus B. NL.
3A minus B.
Yes, I nearly put minus 3A then. 3A minus B. N to K. 2A minus B. Yeah, because it's 3A minus B minus A, which is 2A minus B. And then K to N. B minus 2A. Okay, but obviously if you think we go A plus B minus 3A. Okay. Number 4. ZX. A plus B. YW. A minus 2B. XY. XY. Minus B minus A plus, which is B minus A. Okay, and then XZ minus B minus A. Okay, question 5. So I didn't tell you this in the question. However, this is a regular hexagon. So we know that this side is actually the same as this one. Okay. Now, how do I know what AB is? Well, I have to think of another way to get there. So I could get there by doing minus A plus B. minus A plus B, okay? That's in this direction. And make sure if you're ever creating vectors, you write the direction, okay? So, AB minus A plus B. FO, well, again, this is regular, so we do know that this is actually equal to this because they're parallel. So this is the same, minus A plus B. A to O.
So how do we get to O?
Here's O.
Yeah, but there's nothing on that line.
Yeah, I'm telling you it's parallel. And it's regular, so it's the same. That's what they didn't tell you in the question. A to O is here. However, I could do minus A plus F to O, couldn't I? So minus A minus, wait there. Minus A plus B is minus 2A plus B, isn't it? And then F to D is, if you think, if I went to F to D, I'd have to go this way. However, I don't know what O to D is. What I do know is this is still parallel to A. So this is A. I know that this is minus A plus B. So, and this is minus A plus B. So if I'm going from F to D, I'm going to get minus 2A plus 2B, and then minus A again, minus 3A plus 2B. Okay? So once you fill everything in, as long as we're comfortable working all this out, this is just ensuring that we can write all this. This is perfect. Okay, the next thing we really need to be comfortable doing is expanding and simplifying. Okay. We should all be really confident at this. Yeah? Shall we do it? Okay, what are we going to get for the first one? So I'm going to get 2A plus 3B. Okay. 2 times A, 2 times B. Do I need to go a step? No?
Just skip.
I did skip a step because everyone said they were confident and we didn't need to do this. Yeah? Are you sure you're confident? Okay. So here I'm going to have a half A plus a half B once I expand and simplify. Okay, are you ready to do the next one? We're not doing steps. Let's go. Tell me what it is. Which is? No, you should be able to do this in one go. 3 over 2A plus a half B. Okay, how about the next one? What do we get? Minus A plus 4B.
I can't do that.
You can do this in your head. I believe in you. Okay, and the next one. We're going to get a third A, 2 over 3 minus B minus a third B. Is that right? Thank you. Okay, is writing a third A the same as writing A over 3? Yes, absolutely. Okay, so I will switch between the two on purpose. You just need to be confident. Brilliant. Okay then, so this is a challenge type question. This is a GCSE question. Okay, so everything we've been doing are literally all the skills and notation. Everyone knows how to do ratio and fractions. Everyone can expand. Everyone can write in ratio form. Well, there are 2 little things we need to know. Apart from that, we should all be able to do this question. Okay? There is nothing I haven't taught you. Everything I've taught you, you should be able to do this question. Give it a go now. Okay, so first of all, let's read what we know. PQRS is a parallelogram. Okay, what does that tell me? I said earlier about parallel sides being the same. So that means if SP is B, that also means QR is B in the same direction because they're parallel sides. And we also know in a parallelogram, not only are they parallel, they're the same length, aren't they? So I wouldn't be multiplying that by a scalar, okay? And then the same as SR is the same as A. Okay, so I always, whenever I deal with vectors, I literally, like, everything will be a clue. So, there we go. It then says, n is the point on SQ such that Sn and NQ is 3 to 2. So you can see here I've written the ratio. However, once I've written the ratio, I then write my fraction of amount, essentially. Okay? So Sn is technically 3/5 of the line. And then NQ is technically 2/5 of the line. Okay? So then I do that part. Check. Okay. Then, PQ equals A, PS equals B. That was already written on. Perfect. So I've already done that. Okay. Okay, perfect. So I make sure I read everything, and anything that needs going on, I do. I have to. Then it says, write down an expression in terms of A and B for SQ. Okay, so SQ is going to be red. Okay, so where is SQ? Okay, so I start at S, and I'm going to go to Q. The director's route would be this way. However, we don't know what this is yet. I am going to go, you can go either way, remember. I'm just going to go from the top. SQ can be represented by SR. Okay, so SQ, that's S to R plus R to Q, isn't it? That's how I've done that. And what are they represented by? S to R is represented by A. R to Q is represented by negative B. So S to Q is A minus B.
Why is S to Q SR plus RQ?
Because I've gone this way. SR to RQ is going to go S to Q. I could have gone SP PQ. Sounds like Pikachu, doesn't it? Right, SP and PQ. That is still B minus B plus A. It's the same. Right, now that we know S to Q, it means any route we have S to Q, we know the total will be this, A minus B. So S to Q, if we went this way, A minus B. If we went this way, minus B plus A. Is that the same as the A minus B? Yes. S to Q. This way is A minus B. Every direction is A minus B. So I know that actually this vector, S to Q, in this direction, this can be written as A minus B. Okay. Then it says express NR. Okay, NR in terms of AB. Okay, so where is N and to R? Now they've actually already highlighted this in purple. So NR, are we happy if we start at N, we could do NQ and then QR. Okay, so this is one way we could do it. So we have NR, and I'm writing this all out step by step for you so you can see it. I've gone NQ, and then I'm going to add on QR. Okay? However, NQ is 2/5 of the line SQ, is it not? So this is 2/5 of, now I'm just going to write SQ here. Okay, which is 2/5 of A minus B. Plus, obviously, our QR. What is QR? B. Now, why do you think we had the starter that we just did? I know what you're thinking. Quick maths. This is going to be 2 over 5A plus 3 over 5B when I expand and simplify. Because I'm going to get minus 2 over 5B plus a whole B, which is 3 over 5. So this is my answer. Okay? Now, as you can see, we laid it all out. All we're actually doing is adding numbers once we figure out a root. In terms of difficulty, is this difficult? No. Well done. Okay then. So, very similar question to what we've just done. I would like you to apply the same theory. Go. Right. Okay, so we have our ratio. we have OA is A, check. OB is B, check. It is a triangle, check. P is the point on AB such that AB to PB is 3 to 2. So I know my ratio is 3 to 2. What does that mean? That means that AP is 3/5 of the line AB in this direction and 2/5. So show that OP. Okay, so first of all we need to work out AB. So AB, why do I need to work that out? Sorry, I've gone a bit fast. OP, how can I do that? O to B plus BP. Okay. However, what is O to P? We know that that's B. What is BP? Well, I know that is actually 2/5 of the line AB. Okay? However, it's going to be negative, that, isn't it? Because we're going the opposite direction, if I've said it this way. There's more than one way to do this question. So it's going to be minus 2/5 of the line AB, because if we say the line AB is this direction, we're going the negative way. So now I need to know what AB is. A to B, I'm not sure, so I'm going to go this way, which is minus A plus B. So my final thing is B minus 2/5 of AB, which is minus A plus B. So I'm going to have 2/5A minus plus 3/5 B. Perfect, I can factorise out a fifth, and I'm left with 2A plus 3B. Therefore, proved. And I've laid out all of my method. We have two types of provey questions, okay? Sometimes they will include the ratio ones that we've just seen, but this is in the GCSE, there's two types, and it's really important that we just recap these. So, the first one is proving that one is a fraction of another or equal type thing, okay? We have the ones that show it's parallel, okay, and then when we have ones that say prove that it's a straight line. We have to be comfortable doing all of these, okay, so these are the types of provey questions, and we're going to look at that. I mean, if you feel comfortable, give these a go, we will go through them later, all right? So, showing vectors are equal, this is the first type of provey question that we're going to look at. Why don't you try and give it a go, and then we will compare and see if you've done it correctly. So, we're going to express AB in terms of A and B. So if I start at A, how do I get to B? Now, obviously, the quickest method is this diagonal line. However, it hasn't told me, I don't know what that is. Is there another route I can take where I know what the lengths, what the lines represented by vectors are? There is, isn't there? What could I do? A, O, O, B. Okay, so remember there's always, so AB can be represented using AO plus OB, which we know AO is minus 3A plus 6B. So minus 3A plus 6B. Okay, so everyone should be happy with part A now. If you're still not happy with part A, you need to go back and look for some GCSE videos, okay? Because we should really all be up to this standard. And remember, this is actually, we're not even at pure 4 yet. This is just GCSE recap. Okay, so X is the point on AB, such that AX ratio, so we know the ratio of AX here is 1 to 2. So first of all, what does that tell us about our fractions? 1 over 3, 2 over 3. There's 3 parts in total. So, then we've done that, and it says BY is 5a minus b. Okay, we can see that that's already on here. Okay, so all the information we need is on here. Prove that OX equals 2/5 of OY. Okay, so I want to go from O to X. Now, personally, if I was going from O to X, I would do OA, AX. Okay? However, you could do it a different way. What could you do? OB, BX, yeah? Okay? Now, some of you are thinking, well, why don't we just go straight here? Well, yeah, of course we could go straight there, but we don't know what that is. We've got more chance of doing OA and AX because we know that this line, AB, we already represented it in the first one. And now that we know the ratio, it's really simple. So, OX, I'm going to go the blue way. If you've gone the green way, we will still get the same answer. Okay, so OX is OA. So, OX equals OA plus a third of AB. Now, lucky for us, when we did AB earlier, we were in this direction anyway. Okay, if it was the other direction, we'd do minus, wouldn't we? OA we know is 3A plus a third of AB, which is minus 3A plus 6B. Okay, so now we're going to do quick maths. Are you ready for this? 3A minus A, 2A. And then we're just going to be left with plus 2B. Okay, so this is my OX. Check. Now, 2/5 of OY. So 2/5 of OY equals 2 over 5, lots of OY. How do I go from O to Y? Now, this is really simple. I'm going to go OB, BY. Okay? OB plus BY. Now, I'm writing this all out just so it's very methodical. So, 2/5 of OB, 6B, plus 5A minus B. Now, I know sometimes we do the quick maths, but just FYI, this is probably where the most mistakes are made in the quick maths, okay? So just do double check. So I'm going to get 2/5 of 5B plus 5A, which is actually 2A plus 2B. Now, what do we notice? They equal each other. Therefore, 2A plus 2B equals 2A plus 2B. Therefore, OX equals 2/5 OY. Now, I know I've shown this really methodical. It's really good to do this especially when it says prove. Okay, you can't just be like, yeah, of course they're the same. I've just worked it out in my head. Okay, we need to show our step by step. So that is the first type of GCSE question when we have to show that something's equal. Okay, what do we notice about these lines again? Yeah, they're parallel, okay? They have the same gradient. They are parallel, they just have different lengths. Okay then, so to prove that a line is parallel, we have to prove that they are a factor of each other. So, for example, essentially, this is A, and this is 2 lots of A. So our factor is A. Okay, they've just been multiplied by a scalar of 2, yeah, a scalar quantity. For this one, A plus 2B, is this a factor? Yes, if I take out 2, I get A plus 2B on this one. Okay, we've proved that. We have A, well, this is minus 3 over 2A. Okay, now even though our gradient in this case is negative because we're going the other direction, it's not quite a negative gradient because lines which go this way are still positive, aren't they? Positive gradient. Even though this has a negative number, it just means that we're going down in this direction. Okay? But all we're doing is we make sure we have a factor of each one. So, are these vectors parallel? It's a yes or no, or a no or yes. Okay, are we ready? Question number 1. Is it parallel, yes or no? Perfect. Okay, they're not a factor. Number 2. Yes, absolutely, because a plus b is simplest form. Can we get that from vector 2? Can we factor out a plus b? We can. 3 lots of a plus b, isn't it? Okay, how about the second one? Yes, what do we factor out? Minus 3 is going to give us a plus 2b, isn't it? So we still got that. The second one, sorry, the fourth one even. Yes, it is. Minus 1, so minus lots of a minus b, okay? If one of your vectors is in its simplest form and you can factor that out, they're parallel. So, here we go. We're going to show 2 vectors are parallel, okay? So, x is on a point on AB such that AX dot XB is 3 to 1. So what am I always going to do? I'm going to write my ratio, and then I'm going to write my fraction. 3 to 1 is 4 parts, and I've done that. M is the midpoint of BC. If it's a midpoint, it's a half. Okay, so that's 1 over 2, 1 over 2. Yeah? Show that XM, okay? So what I like to do is XM, I do that first. If I start at X, and I go to M, is everyone happy? Yeah? This is how I'm doing X to M. If I look at this, what have I actually done? I've done a quarter of AB in this direction. And then I've done a half of BC in this direction. That's what I'm saying, isn't it? Okay. And then it's parallel to OC. Okay. So remember, what is this? XM. So we need to prove that XM and OC have a common factor. So an OC, personally, how would I do OC? I would go OA plus AC. Okay? Equals OA plus AC. Okay. Now, the question has actually missed out a crucial thing. It tells us in the question, but we didn't write it, it's misprint. This is a parallelogram. Okay, it tells us in the question this is a parallelogram. Imagine it tells us this. Yeah, parallelogram. Have I spelled that right? No, I didn't. Parallel.
Can we actually learn it?
Oh my golly, right, sorry, let's brain freeze. Okay, we'll spell that another day. Right then, so OC. Okay, so if this is A, in this direction this is A, isn't it? And if this is B, this is B as well. Okay, so we focus on one thing at a time. Should we do OC first? Okay, so OC is, what's OA? A. What's AC? B. Perfect. So that's nice and easy, isn't it? Okay, let's focus on the next one. A quarter of AB. Quarter of AB. What is AB? A to B. Not quite. This is negative A plus B. Yeah? So, negative A plus B. And then plus a half. What is B to C? B to C is still in this direction, so this is A. Okay, so quick maths. I'm going to get a quarter A plus a quarter B. Okay? And if I expand and simplify everything. Yeah? Then I factorize out my A plus B.
How do you do that in your head?
Okay? I did it in my head. You know, sometimes my head, I'm very good at mental maths. Okay? Letters, like today I've got a headache, I can't spell. But it's okay, we all have good and bad days. Right, a quarter A plus B And then we have our A plus B, yeah? Okay, some people in my classroom are confused. Okay, let's just take this slow. A quarter times negative A is negative a quarter. Plus a half is positive a quarter. Okay, this is how I got this. A quarter times B is just a quarter B. Use a calculator if you need to. Okay, please do. Right then, so then, what do you mean how? What's a half take away a quarter? Do we have to do a lesson on fractions? Right.
Yeah, makes sense.
Here we go. This is a chocolate bar. This is half if I shade in 2 quarters. If I take away a quarter, how many do I have left? 1 quarter. We need to be chop, chop, chop. Okay, guys. So, then what do we have? So we have OC equals A plus B. And then we have XM equals a quarter A plus B, okay? Doesn't matter which way round you say it. You can say OC is a factor of XM, or XM is a factor of OC. Therefore, they are parallel.
I said they're parallel doesn't mean they're both.
I can spell again. Pardon?
They're parallel doesn't mean they're both half. Because M.
If they're parallel, they share a common factor. Their common factor that they share is A plus B. They've been multiplied by scalar quantity. This is a quarter of A plus B. So this is a quarter of the length of what our A plus B is. Okay? Okay, so here, give this one a go. So what is A to B? So minus 2A plus 3B, yeah? Then P is the point such that AP, so this is 2 to 3. So what do we have? 2 out of 5 and 3 out of 5. So now I need to find OP. So OP is OA plus AP, isn't it? Okay, and I love getting my highlighters out, just drawing this. OA, AP. So O to A, 2A. And A to P is 2/5 of AB, which we worked out earlier, which is minus 2A plus 3B. Okay? So then, 2A is minus 4/5 is 6/5 A. And then 2/5 times 3B is 6/5 as well. And this we can rewrite as 6/5 brackets A plus B. We can see that they're both a factor of each other. So of course it's parallel to AB because AB is also a factor here. We've multiplied it by a scalar of 6/5. Yeah? Okay. Proving 3 points are a straight line. Now this is really easy. We have to prove, first of all, that they're parallel. Yeah, they have to have the same gradient. And they have to share a common point in the middle. So we need to prove that AB, because B is the middle one, is parallel, so like is n lots of AC, if that makes, BC. Well, no, okay, wait there. That's probably not the best way to write it. Because technically we want to show that n lots of AB equals to BC, don't we? Yeah? So we need to show that n lots of AB equals to BC, and then they share the common point B. Okay? So they're parallel and they share, and the middle point should always be the one that they share, obviously. Okay? So they share a point and they're parallel, therefore it must be on a straight line. So here is a typical straight line example question. So, B is the midpoint of AC. So what is this going to be? A half and a half. Okay? It doesn't tell us anything about n, but we know that this is 2/3 and this is 1/3, isn't it? Okay? So, it says find PB. So P to B. Now, I can't go this way. Why? Yeah, we don't know it. So I'm going to have to go around this way.
How do you know they're parallel?
Yeah, I see. Okay. Anyway, I forgot. Oh, no, I'm back to here. So I can't go PB. However, this is the direction I'm going. So I always write the direction on here. Okay, so PB is P to A, and then A to B, isn't it? So this is minus B, minus 2B is minus 3B plus A. So this is A minus 3B. Okay? So this is A. So this is a half A minus 3B, and this is a half A minus 3B, because we just worked out P to B. It then says, show that NMC is a straight line. Sorry, I forgot this. What did it tell us earlier? B is the midpoint of AC. So if this is A, what's this? A. Okay, remember to write everything down as let's just go back. I forgot the most important step. Step 1. AN, 2B, NPB, that's on the, B is the midpoint of AC. Oh, okay, so that's A, check. M is the midpoint of PB, a half, check. Okay. Always make sure you've written everything down, or else we would have looked at that question and thought we've got missing information. So to show that NMC is a straight line, we need to show that NM is parallel to MC. And what do they share? They share the common point M, which is in the middle. And if we were to draw a straight line, NMC, that's what we're doing. And M is our middle one there, isn't it? So, first of all, we've got to find NM. Personally, I'm going to go this way. N to M, I'm just going to do NPPM. So, NPPM, which is B plus a half A minus 3B. So I'm going to get minus 3 over 2. I'm going to get half A minus a half B. That's what I get for NM. Okay? Then I now need to do MC. So I'm going to start at M.
Supposed to be the same thing.
So now I'm going to do MB to BC. So MB is a half A minus 3B plus BC, which is A. Okay, so a half A, so I'm going to get 3 over 2A minus 3 over 2B. Okay, I can clearly see that A minus B is a factor of both of them. So if you wanted to, you could take a half out, A minus B, 3 over 2 out, A minus B. Okay? So you now need to say, therefore, NB is parallel to MC. They share a common point M, therefore NMC is a straight line. And sorry, I just realised I just wrote the vector thing on top, which I don't need to. Okay? That is how we prove this is a straight line.
It's parallel to what?
Okay, here we go. Here is for you to try your understanding. Okay, so write an expression for ON. So how do I get from O to N? What's the first step we need to do before reading the question? Highlight, we got everything. OA is A, check. OB is B, check. D is a point on AC such that AC equals AD. Okay, so we don't know that yet. However, we know that these two are equal, right? They'll be the same. The point N divides AB in the ratio 2:1. Okay. 2:1, 2 over 3, 1 over 3. Brilliant. And write an expression for ON. Okay, perfect. So ON. How do I get there? I need to do ON is 2/3 of AB, isn't it? ON is 2/3 of AB. How do I get 2/3 of AB? Well, A to B is minus A plus B in this direction. So 2/3 of minus A plus B. And I'm going to get minus 2 over 3A plus 2 over 3B. Perfect. Okay. So far I've got 2/3 AB, but it was ON, so I need to add A. So plus A. So I'm going to get 1/3 A plus 2/3 of B.
Yeah, that looks more right.
Brilliant. So that is ON. O to N.
You get that?
Because OA,
So I got 4.
AN. Okay, the next question says prove OND is a straight line. So OND is a straight line. So what do we need to prove? That ON is parallel to ND. What shape do we have here? Parallelogram. So this is B, this is B. So O to N, we just worked out, didn't we? 1/3 A plus 2/3 B. I can factorize out 1/3 A plus 2B. Okay. Now, ND. Is that right? ND, yep. Okay, how do I get from N to D? Well, I'm going to do minus 2/3 AB plus 2B. ND, because we went the opposite direction, is minus 2/3 AB, which is plus 2B. So I'm going to get positive 2/3 A, 2B minus 2/3 is negative 4/3 B. Perfect. Now I'm going to factorize out minus 1/3 minus 2/3. I'm left with A plus 2B. Okay, we can see that they both share a common factor. They also share a common point, therefore straight line. Okay, so that's done. Okay, this is the basics of vectors. I suggest doing some of the IGCSE past paper vector questions to get a bit more of an understanding. Okay, also for a bit more understanding, in the book, chapter 7A, page 101 and 102, I suggest going through and picking some of these questions, okay? Page 101 and 102, and then we're going to move on to pure 4 vectors. Well done.